Okay, cool. Thank you so much for the introduction. And I will indeed be presenting on the 2022 April floods. Now, I made a slight mistake in my abstract, but just to clarify, I will be highlighting the role that certain mesoscale weather systems played in contributing to this heavy rainfall event. And we published a paper, my supervisors and I, and this presentation is just highlighting some of the main results of that paper. So, um, right. So these are just some images that show the devastating aftermath of the flooding event that occurred over the KwaZulu-Natal province in South Africa. And over some stations, over 300 millimeters of rainfall was received. These are daily records. There were hundreds of deaths, tens of thousands of people were displaced, there were missing people, and generally there was just such an extensive, the degree to which there was damage was quite extensive. And so for this region, there was a national state of disaster declared by the president just in response to the flooding that occurred. Uh, Now, a lot of the conversations in the public used these descriptors for the heavy rainfall event. So phrases such as an unprecedented event or climate change. And in fact, this was a remark made by the Premier of KZN in 2022 that this weather phenomenon that is unprecedented in the history of our province and perhaps that of our country. Now, in terms of rainfall, let's look at the historical records, and can tell us a little bit. Sorry about that. This can tell us a little bit about whether indeed this was true, an unprecedented event. And we can observe that in the previous century, we've had daily records of about 400 millimeters. This was in May 1905, 250 millimeters, August 1968. And if we're to look over a period of days, I would like to bring your attention to September 1987, where 800 millimeters of rainfall was received in just 5 days. This is roughly equivalent to the annual average of this particular region. So, in terms of the rainfall event, this isn't really an unprecedented event, but perhaps through some investigation, we can uh, outline the unique characteristics that really made this a special event. And I'd like to just briefly show you the domain. It's KZN is in southeastern Africa. It's a province in South Africa, but I looked at the coast of southeastern Africa, and I also included a station in Mozambique, or a few stations in Mozambique. But these were the stations that I was provided with daily rainfall data. And so this is what I'll show you. And huge thanks to the South African Weather Service and the Meteorological Institute of Mozambique for providing me with the data. So what I'd like to highlight is that during the course of this event, there is this key characteristic of the event is this southward migrating rainfall maximum. And what we observe is that on the first day, the rainfall maximum is located more towards the north, and on the second day it moves southwards. So there's still a bit of rainfall in the north, but the heavier rainfall is relatively heavier rainfall is being received in the central and southern stations. And by the 12th of April, there was little to no rainfall in the northern and central stations, and it was just these two stations towards that are located in the southernmost extent of this particular domain that received heavy rainfall. And I would like to explain the reason behind this unique characteristic of the extreme events that was observed in 2022. And just briefly, I'd like to outline or show you the weather systems that typically we expect to produce extreme rainfall. This was work done by a colleague, and we can see mesoscale convective systems, cloud bands, cutoff lows, tropical storms, tropical lows. But even within this group of 5 weather systems, there is variation in the spatial scale, and they range from the mesoscale to the synoptic scale. So even in this talk, I'll structure it such that one, I highlight the synoptic background, then later on I will show you the mesoscale weather systems that also further influenced the pattern of spatiotemporal variability. So for the synoptic features, The large-scale circulation was dominated by one, the cut-off low. It was a persistent cut-off low over the interior of South Africa. I think this was pretty much well understood because even in the press releases, people would say, "Oh, there's this heavy rainfall event linked to a cut-off low." So what I'd like to focus on, the other two, there is the ridging anticyclone southeast of KZN, and linked to this anticyclone are low-level easterly jet that was in the southern Mozambique channel. This figure on the left shows this zonally extensive anticyclone. This is 925 hectopascals geopotential height and moisture flux. And what we observe is that at the northern flank of this anticyclone, below Madagascar, strong positive moisture flux was observed over this region. And what we did is we took a transect along this region and plotted zonal winds. And this just shows that at the lower level, there is easterly flow. So this is just showing the zonal wind. So it's taking this easterly direction, and the flow is towards the coast of KZN. So this what we found out is that there's an onshore low-level jet towards the coast, and so this obviously would presumably would say that this is supplying moisture towards KZN. And if we look at the southwestern Indian Ocean, we observe that there was a band of enhanced latent heat loss, and this is linked to the long easterly fetch that was associated with the very extensive anticyclone. So there is increased latent heat loss. This is supplying moisture to the jet and to KZN. And also, if we look at the positive sea surface temperature anomalies, which were higher than the typical canonical La Nina event, and generally during April, in the climatology observe positive sea surface temperature anomalies. So in the southwestern Indian Ocean, we have a conducive environment for increased rainfall if we pair all these things together. And so in conclusion, like this slide just shows that the southwestern Indian Ocean supplied moisture to this strong low-level jet. And we took this a bit further, took a step further, and performed a backward trajectory analysis. All this was doing was that we took air parcels in these various stations along the coast and then performed backward trajectories. So this uses gridded data sets. We used Area 5 and computes the trajectory so that it's looking at the advection of these air particles. And what figure A shows is that these brighter colors, so up to the yellow, shows that about 80%, up to 80% of the trajectories were tracking through this region of enhanced latent heat loss. And here in figure B and C, I just computed the changes in specific humidity. But all you need to know is that this blue up is showing an uptake of moisture. So from the perspective of the air particle, it's taking up moisture. And this again is just highlighting that the southwestern Indian Ocean, just east of KZN, was an important moisture source. So as opposed to sometimes we had these remote sources, here we had a moisture source that was quite close to the region where the heavy rainfall occurred. Okay, and now these are some of the more interesting features. The mesoscale, which is on a much smaller spatial scale. During the course of this event, on the 11th of April at about 3 a.m., there was a mesoscale convective system. And this is just a cluster of thunderstorms that are operating as a system. You can observe this in the region of purple. So this is just cold brightness temperature, this region here. And this is showing that there was an MCS just hugging the coast in the north of KZN and also just in the very southern tip of Mozambique. And how this system moved is that it moved slightly southward and offshore, progressively moved offshore. And then later on, we see this MCS, right? It's moved offshore. But now we have a mesolow, and this is just a coastal trough. So I'm calling it a mesolow just because of the scale. And this is a coastal trough that has developed along the coast of KZN. and it strengthens and it migrates southwards along the coast of KZN, but later on it moves offshore, and this is what we think strengthened into the subtropical depression ESA that was flagged a bit later. And these mesoscale features and their interactions are really what is producing this spatiotemporal variability, where we find heavier rainfall towards the north, and then the rainfall maximum moves southward. And what I'm showing you here is moisture flux convergence in the purple, and this is a bit earlier on in the day when the MCS is quite close to the northern coast. So what this is doing is producing a stronger convergence, stronger uplift over the northern coast, and this is when indeed we saw the northern stations recorded heavier rainfall. But afterwards, if we look at the vectors, the moisture flux vectors, we see this diversion towards the south. So they're changing direction. This onshore level flow is becoming more northeasterly, and that's because when we observe the troughing that begins and then we eventually the mesolow develops, what is happening is the jet is being diverted towards the trough, the low level, the region of low pressure, and so moisture is also being diverted away from the north and towards the south, and this pattern continues as the mesolow progresses and migrates southward. So we have this in these interactions where from the mesoscale features influencing the jet and the influencing the rainfall maximum. So all in all, back to the question, was this an unprecedented event? So, according to the results of this particular paper that we produced, yes, it was unprecedented in terms of the kind of interactions that led to the event. So, we have these mesoscale interactions between an MCS, mesoscale system, mesoscale convective system, and a mesolow interacting. And this hasn't been documented previously, at least to our knowledge, in the southern hemisphere. And it's really just this unique combination of factors that produced this event. It's like it was just ripe for disaster. Everything was there: the cutoff flow, the anticyclone, this strong jet, then the mesoscale features and their interactions produced heavy rainfall. And it's also interesting to think of, okay, what would happen if we didn't have that MCS and that mesolow? Perhaps there would have been persistent heavy rainfall in the northern stations, and it's interesting to think of these things because they can influence the rainfall patterns for better or for worse. So I will just summarize by saying that the synoptic conditions were favorable for the formation of rainfall, but when we with this key characteristic of the event, which is a southward migrating rainfall maximum, what we see is that the mesoscale features are what played a more important role in influencing the low level jet, which is the main moisture transport. Um, and this in turn influences the regions of moisture flux convergence and uplift, and this in turn influences the position of the heaviest rainfall. And again, just to highlight that this kind of interaction hasn't really been observed before, but it's good to highlight it because for the future, in terms of ocean monitoring, or we can flag these systems and perhaps have a better idea of what their interactions could produce and be able to warn people in time. So thank you very much. I will, should I keep my slides on, or
Yeah, you can keep
we can,
slides.
yeah, we can go back to it if there's,
Yeah, if there's any question. Do we
if
have
there's
any
a question.
questions in the audience? Let's see in the chat. Thank you, Wanjiru. I do have a few questions. Has there been any cases like
Okay,
this in
great.
the past, like similar cases where you have those mesoscale, mesolows and how do you call that?
So there's a, yeah, a mesoscale convective
Yeah, convective.
complex and then mesolow. No, to okay. So to our knowledge, no. At the in terms of just the combination and the co-occurrence and how they influence each other, no. But I wouldn't be surprised that if we actually had access in the past to perhaps the satellite imagery that I just showed, maybe this would come up in like, for example, the events that we saw in the 1905, 1968, perhaps would have been able to see them. So just in terms of scientists being able to flag it, no, but perhaps it has occurred before.
But it hasn't been reported. So we have one question in the chat. Was the event able to be predicted by the forecast models, the early warning systems? Yeah. Was the rainfall, for
Yes.
example,
So,
accurately predicted?
mhm, yes, I believe it was accurately predicted, and that the breakdown occurred between disaster management or the people who are responsible for warning. Because if you do look at the SARS press releases, they do indicate, maybe not to that degree, but the levels were in the red zone. So I think some of the challenges with such events is the non-climate related factors, which are, one, the people who are in informal settlements in already landslide prone areas, the dissemination of information, and even when people are warned, sometimes they just don't know where to go. So all these factors contributed to that. But I do think that SOS did its job in the most timely manner that they could in terms of warning. Yeah.
Perhaps also the increase in population in coastal regions have increased, also that probably you had a lot of landslides,
Yeah.
like areas where,
Yeah.
yeah, you
Yeah.
shouldn't be building.
Yeah.
Okay, do we have any more questions?
Maybe I can
If you don't have
ask.
another question, oh,
I
sorry.
think Femi has one.
Hi, Wanjiru. Thank you so much for your nice
Hi.
presentation. I was just wondering, what do you I saw that you had a slide on climate change, but I didn't have time to read it. I was just wondering
Yes.
how do you see it in the future under anthropogenic climate change? Do you see it happening more often, or is it just really a special event where you need to have these different mechanisms happening at the same time? So then obviously it makes it
Yeah.
harder to predict in the future, right?
Yeah, thanks for that. I was actually gonna go back to this slide. I'd saved it. I wasn't sure about time, but I'm glad we can talk about it. So while I didn't really look at climate change, this is what some scientists say. There was one study that it was kind of an attribution study, and what they found was that the probability of having such an event would be twice less likely if we didn't have the amount of if we didn't have the temperature increase that we do have at the moment. So they said if temperatures were about 1 to 2 degrees lower, this wouldn't be an event that occurs as frequently as we can now expect it to. Now, attribution studies are usually so tricky and difficult, but in terms of having a combination of factors that can use these events, I do think we increased frequency of extreme La Nina events. This I've just highlighted the research that showed that there's a likely increase in the extremes of La Nina. So this was occurred during a protracted La Nina event. Sorry, I didn't mention this, and this is just the prolonged La Nina seasons. And during cutoff flows, and that's one of the main contributors of heavy rainfall events, sea surface temperatures in the Indian Ocean also differ from the typical sea surface temperatures that in the climatology. And then also research suggests that we would have an increase in the frequency of MCSs. So if we're to look at all these, then we can say perhaps the likelihood of having these interactions, these very unique interactions, might increase. And I think I'd like to keep it at those conservative. But yes, I think we can expect an increase in the frequency of these events, of such events.
Thank you,
Thank you.
Wanjiru. Can you perhaps go back to your moisture trajectory, um, the tracks that you have?
Figures. Yeah.
And if I can see
Okay, let's
it.
see. Sorry, my computer is a bit.
It's a bit, it's lagging a little bit. I just wanted to ask if you've done
Okay.
something similar for La Nina events only, like see how these trajectory changes during La Nina and how long does it take to, like the moisture to reach the coast of South Africa?
Mm. Yeah, and unfortunately, I haven't. That was my initial plan, but with load shedding, it just wasn't a sustainable plan because it's very data intensive. These the backward trajectory analysis. So unfortunately, I haven't analyzed any other event. But at the moment, I'm trying to do the same thing, just even without high split. But comparing protracted La Nina events and the rainfall that occurs during these events with just the typical single season La Nina events and also neutral seasons, and just looking at the differences in rainfall. And it's surprising that during some events, you actually have events that have negative rainfall anomalies really below the 10th percentile, and during others you have those positive rainfall anomalies above the 90th percentile. So I don't think we can always just give this direct relationship, or how sometimes there's just this fear that the media invokes in us, and they say, oh, there's this La Nina or there's El Nino and we'll have drought or we'll have floods. It's never as clear cut, and I think that the data shows us that.
Perhaps depend on different flavors of Enzo as well, not only
Yes.
different index.
Yes, yes. And Lerato actually is doing that kind of work to show the different kinds of SST anomalies for the ENZO and the rainfall characteristics. So that will be interesting
That would be
to,
interesting
yeah, yeah,
to link with your study. Do we have any
yeah.
more questions? Okay, I think if we don't have any questions, thank you so much, Wanjiru, for this amazing presentation. I think you've done some excellent work here. Yeah, so I wish you all the
Thank you.
best with
Thank
your
you for having
PhD.
me.
Yeah, all the best with your
Thank you.
PhD, and we'll see everyone next year. I think the next session will be in February. Okay, thank you, everyone. Enjoy the festive
Thank
seasons.
you. All right. You
Cheers.
too. Okay. Bye.
Thank you. Cheers.